Welcome to the FinGlimpse podcast, where we analyze the world of business, finance, and the economy. We cover the latest market news, economic trends, and some interesting businesses. As a standard disclaimer, this podcast is for informational purposes only and should not be considered investment advice. Always do your own research. Now, let's get started.
Welcome to the deep dive. Today, we're looking into something really critical for a lot of modern tech, especially cars, rare earth magnets. We're going to explore some recent turbulence in their supply chain and how that's hitting the auto industry specifically.
Yeah, it's been making some waves.
We've got a bunch of sources here, reports, articles, including a recent update from Nuvama Wealth Research to guide us.
Good stuff?
And our goal, really unpack what's happening, figure out the actual impact, and pull out the key bits so you can feel properly clued in. Okay.
Sounds like a plan. Let's get into it.
Right. So rare earth magnets, it sounds kind of niche, but they're actually, they're pretty fundamental, aren't they?
They really are. And that name rare earth, it can be a bit confusing. We're talking about 17 specific elements.
Okay.
You know, the lanthanides plus scandium, yttrium. They're not actually like rare in the ground in small traces.
Oh, okay.
But finding them concentrated enough to mine economically, that's tricky. And maybe even more important, they're really hard and energy intensive to separate once you've mined the ore.
So it's the processing, the separation. That's
Right.
the real challenge, not just digging them up.
Precisely. And that difficulty is central to the whole supply chain story. Now, the magnets themselves, REMs, are made from these elements.
Right.
You mostly hear about two types. Neodymium iron boron, that's NdFe, the most common one, and samarium cobalt, SEMINGO.
And why are they so important? What makes them special?
Well, they just pack an incredible magnetic punch for their size. You get much higher efficiency, better torque to size ratio. They can be something like 15 times stronger than a traditional iron magnet of the same weight.
Wow, 15 times.
Yeah, which makes them indispensable when you need high performance in a small space. Think electric motors, primarily.
And you mentioned the processing challenge,
Yeah.
which leads us straight to China's role in all this.
Mm.
The sources say they pretty much dominate.
Oh, dominate is maybe an understatement. China mines about 70% of the world's rare earth elements.
Okay, 70% mining.
But the real choke point, the control, is in the processing. They handle over 90% of the global refining, that really complex, energy-hungry separation process.
Over 90%.
Yeah, and over 90% of the manufacturing that turns the refined elements into the actual magnet materials.
So they effectively control the whole chain.
Pretty much, especially for those key magnet elements needed in EV motors, neodymium, praseodymium, dysprosium, and terbium. China refines well over 90% of the global supply of those four.
So even if other countries, like say the US or Australia, mine more rare earths, they still often need China for that crucial refining step.
Exactly. That's the bottleneck, the capacity, the expertise for refining and manufacturing. It's just heavily concentrated there. We're talking 92% globally. Building that kind of capacity elsewhere is, it's a huge effort. Costly, takes years.
And this concentration, this dependency is really come into focus because China recently put some export restrictions in place.
That's right. Since April, they've restricted exports of 7 specific rare earths: samarium, gadolinium, terbium, dysprosium, lutetium, scandium, and yttrium.
What's the official reason given for that? And what are we seeing as the actual effect?
Well, the stated purpose is mainly about national security. You know, the defense sector uses these high-performance magnets too.
Right.
But the ripple effect goes way beyond defense. It hits global supply chains for auto, industrial companies, aerospace, lots of sectors.
Okay, but interestingly, you said the main elements for the common NdFeB magnets, neodymium, iron, boron, they weren't restricted initially.
Correct. But, and this is where it gets a bit subtle, they did restrict terbium and dysprosium.
And why do those two matter for the NdFeB magnets?
Because those are critical additives. They're mixed into NdFeB magnets that need to operate at high temperatures, like in EV motors.
Yeah.
They help the magnet keep its strength and efficiency when it gets hot.
I see. So without them.
Without them, the magnet might lose performance or even demagnetize at the temperatures needed in something like an EV motor. And SEMCO magnets are directly hit because samarium itself is on the restricted list.
Gotcha. So it's not a total block on the main magnets, but it hits key performance aspects for high demand uses.
Exactly. It affects the high performance versions needed in many applications.
Okay, let's bring this down to the road. Cars. where do these magnets actually pop up in a typical vehicle?
Right. Well, REMs are in more places than you might think in a modern car. The biggest one, and the one most affected here, is the main traction motor in EVs and hybrids. Those almost always use high-performance ND-EB magnets.
The main drive motor. But they show up elsewhere too.
Oh, yeah. You'll find them, or potentially ferrite magnets, in other spots. Depends on the car, the performance level.
Ferrite, what are those?
Ferrite magnets are an older technology, much cheaper, less powerful, and crucially, they don't contain any rare earth elements.
Ah, so they're not affected by these curbs.
Correct. They're fine for, basic window motors, standard speakers, that kind of thing. But, and this is key, they just don't have the magnetic muscle or the temperature stability for high-power jobs.
Like an EV motor.
Exactly. Or advanced power steering, high-end audio. You can't just swap an REM for a ferrite in those applications.
I see. So applications like sensors, power steering, maybe door locks, windows, wipers, speakers, seat motors. Some might use REMs, some ferrite.
Right. Ferrite for cost-sensitive or lower power needs. ND-Fe, where you need miniaturization or high performance.
And this distinction is why conventional petrol or diesel cars, the ICE vehicles, are less impacted.
Yes, much less. Many of their smaller motor needs can be met with ferrite, and they don't have that big REM-heavy traction motor like an EV.
So focusing on the impact then, it really zeroes in on EVs, right? That's where the dependency is highest.
Without a doubt, almost all modern EVs use permanent magnet synchronous motors, PMSMs. They're efficient, light, powerful, great for range.
But they rely on these rare earth magnets.
Heavily.
And the numbers really show that difference in usage.
They do. Our source breaks it down. An average EV uses about 0.8 kilograms of REMs.
Yeah.
Compare that to maybe 0.5 kilograms in a hybrid and just 0.1 kilograms in a conventional ICE car, mostly in tiny motors or sensors.
So much more in an EV.
Yeah, and it varies a bit within EVs too. Dual motor ones use the most, maybe 0.82 kilograms, single motor around 0.55 kilograms, hybrids around 0.51 kilograms.
So the order of impact is pretty clear. Electric cars first, then hybrids, then electric two-wheelers.
That's the order of dependency, yes. Electric passenger vehicles, hybrid PVs, electric two-wheelers face the greatest potential impact.
Now, the Nuvana report, looking at India, had an interesting point about the overall market impact there.
Yeah, it highlighted that because EV penetration in India is still, relatively low, maybe 7% for two-wheelers, just 3% for passenger cars, the total impact on the entire Indian auto market might be somewhat limited right now.
So not a crisis for the whole industry, but a very focused problem for the EV segment.
Exactly. It doesn't mean the problem isn't real, but it's concentrated in that growing EV space.
And within that space, some specific companies in India are already feeling the heat. This is where it gets really interesting. Tell us about the specific examples from the sources. Maruti Suzuki.
Right. Maruti Suzuki India, MSIL, they were reportedly one of the first to face issues. They've apparently cut production volumes for 2 months already because of this.
Really cut production.
Yeah, and they've slashed their EV production target for fiscal 26 quite a bit, from 85,000 down to 65,000 units. Their domestic e-Vitara EV launch is also delayed.
Delayed, wow.
There was a quote from an executive basically saying, IC cars need fewer REMs, EVs need more. They're not in a crisis yet, but clearly the EV side is affected.
Okay, so it's hitting their EV plans directly. What about others, like TVS or Bajaj in the two-wheeler space?
TVS Motor and Bajaj Auto both warned about potential production disruptions, maybe starting as soon as July. They apparently only had about a month's worth of REM inventory.
Only a month. That's tight.
Very tight. And given their EV sales are growing Bajaj around 11% domestic 2W, TVS 7%, it's a real concern for their electric scooter production.
How about Mahindra?
Mahindra and Mahindra MM seemed a bit better off, maybe 2 months of inventory. They mentioned looking actively at de-risking, finding alternatives. Their EV exposure is currently quite low, maybe 1% of PV sales, which buys them some time.
And the companies that only make EVs, like Ola or Ather.
Yeah, for the pure-play EV makers, Ola Electric, Ather Energy, the source expects a big impact. I mean, 100% of their business relies on EVs, so any RM shortage hits them directly. It could definitely affect production and likely profitability.
And on the other end, Hero MotoCorp or Honda's bike division.
With very low EV sales currently, less than 2%, the impact on them from this specific issue is expected to be pretty limited.
And the overall potential consequence for consumers, besides maybe waiting longer for certain models?
Well, the fear is price increases,
Yeah.
similar to what we saw with the chip shortage a couple of years back. Supply constraints tend to push prices up, especially for the affected EV models.
Okay, so besides the actual supply being tight, there's another layer of difficulty just getting the paperwork done, the bureaucracy.
Absolutely. This raises a key question. Why is it apparently so hard for Indian companies to get the necessary approvals from China, even if supply is theoretically available? The process described is intricate.
Walk us through that. How complex is it?
Okay, get this. It's apparently a 7-step process.
Certain steps.
Yeah. First, the Indian company gets end-user certificates notarized in India. Then, India's DGFT attests them. Then, India's Ministry of External Affairs verifies them. Then it goes to the Chinese embassy in India for their approval.
Okay, that's 4 steps already, just getting it out of India and approved by China entity.
Right. Then those approved certificates go to the actual supplier in China. The supplier then has to apply to the Chinese government for permission to export specifically to that Indian buyer. Only after the supplier gets that green light can they ship the magnets.
Wow, that sounds designed to take time.
It certainly seems that way. The sources say it should take about 45 days, but it's been moving at a snail's pace.
Why so slow?
Attributed largely to the ongoing trade war or tensions between the countries. As of late May, the report mentioned around 30 Indian firms had applied but heard nothing back.
Nothing.
And Sona BLW Precision Forgings was highlighted as the first Indian company to actually get an application formally rejected under this new system. That's a pretty clear signal of the difficulty.
Oof, that's tough. But you mentioned a potential positive sign more recently.
Yes, just a glimmer perhaps.
Yeah.
An NDTV report around June 11th indicated the Chinese government might be becoming more open to granting these licenses, specifically to Indian auto companies.
Oh, any movement since then?
Well, media reports followed up suggesting maybe around 10 companies are now somewhere in the approval process, seeing some movement. The auto industry body, SIAM, apparently has a list of over 30 suppliers needing approval. So the bureaucracy is still there. It's not suddenly easy, but maybe the logjam is starting to break a little. So a bit of cautious optimism on the bureaucratic front, perhaps. But fundamentally, even if the paperwork flows, are there easy ways around this dependency? Product alternatives? Supply chain fixes?
Not really, not easily. As we discussed, product alternatives for these high-performance, high-temperature magnets used in things like EV motors are very limited, according to the sources. Ferrugia just doesn't cut it.
Right.
And building up significant alternative supply chains outside China, the refining, the magnet manufacturing, that's a massive long-term investment, years and billions of dollars. It's happening slowly, but it's no quick fix for today's issues.
Okay, so let's pull all this together. For someone listening, maybe thinking about an EV, maybe just interested in tech and global trade, what's the key takeaway here?
I think this situation, looking closely at rare earth magnets in the Indian auto sector, it really serves as a clear example of a much bigger issue. While, yes, the Nuvama report notes the overall impact on India's total auto market might be contained for now because EV numbers are still relatively small.
Right, the 3% and 7% figures. Exactly. But this deep dive shows how vulnerable specific, really important, high-growth segments like EVs and their suppliers actually are. It underlines how, geopolitics and these super concentrated supply chains for critical materials can cause very real, very specific problems.
Like production cuts, delayed launches.
Right. Delays, potential price hikes, it all stems from this complex interplay. The recent news on licenses might offer some hope on the paperwork side, but that core dependency, that remains a big factor to watch.
It's definitely a tangled web tech, trade, global politics all wrapped up together. Thanks for helping us unravel some of it.
My pleasure. Always interesting to dig into these things.
So this situation with rare earth magnets, particularly for EVs in India, it's really just one specific example, isn't it? It shows how reliant modern tech is on certain materials from supply chains, often controlled by just a few players. As more industries electrify and evolve globally, you have to wonder, how might similar choke points for other critical materials, lithium, cobalt, silicon, who knows what's next, create unexpected ripples? What does that mean for innovation, for market stability, even for the products you might want to buy in the future? Something to think about. We'll catch you on the next deep dive.
That's all for this episode of the FinGlimpse podcast. If you found our discussion insightful, please consider subscribing and leaving a review. We'd love to hear your thoughts and suggestions for future topics. Until next time, stay informed and make smart decisions. Goodbye.